Hey everyone, how are we doing? Just grabbed a snack real quick. What are we going to talk about? It is office hours. I think a lot of people want exam or quiz 2. That's what the theme was during office hours. Let's go, says Jackson. Jackson, let's throw out 100 points. Mubot is here, Jackson, and Jackson is here. So what do people want to do with these office hours here? Make sure to say hey and talk in the chat if you want to grab those points. Only way you're known to be here is every 15 minutes if you talk, Mubot sees you. What are you working on quiz 2, Meredith? Name the question, tell me the start of it, and we can start quiz 2. Good stuff right there. Assignment manager, quiz 2. The quiz. What do you want to do on the quiz? We love those points, says Marjorie right there. More points. Everyone's saying quiz 2. Show the bunnies. Here's the bunnies. Bunny in the chat. I wonder if... I feel like Jolly... I don't know. Oh, go wash my hands if I picked up the bunny afterwards. So maybe... almost like at the end of the stream. Would Jolly let me pick him up and walk over here with Jolly? Would he be like, which one do we want to work on right here? Name the question, we shall work on it. I'm going to get quiz 2 up and going. Quiz 2, I think, is due tomorrow. Well, that was quiz 1. I was like, why does that say? I was like, that's due on the 1st? I was like, how is quiz 2 already due? How did that happen? Oh my gosh, there's lots of questions here. There are lots of questions. Who's got a question they want us to do on quiz 2? There are a lot of questions. There is a lot of questions. So what do we want to do? Name the question you're working on. We shall do it. Which question shall we do? So just tell me that, like, what the question says, and I'll find it. Because my questions will be different numbers than yours. Which one shall we do? I'm gonna put some sound. I just did the one on life expectancies. Life expectancies, okay. How does it start out? Like, if you just tell me the start of it, like... there's a fatalities with floods. I think I found life expectancies. Life expectancies. Found it. They come in the histogram. Yep. Awesome. Okay, let's do life expectancies. Okay, so this is Stat 201, and great job for putting these in the chat. Chapter 2, quiz, life expectancies. If you start, awesome. Let's check that out. Thank you, Jackson and Tara and Meredith and Blake. Let's go check this out. 5, 10. Here we go. Life expectancies. Let's do this. Okay, so we're reviewing chapter 2. I like it. We got a lot of questions in the chat. And we'll do floods next here. So the first thing it asks is the shape. Now, when we're talking about data, we want to talk about the what. What 3 things do we talk about when we talk about data, which is quantitative? The 3 things we talk about when we talk about quantitative data are the what. Oh, that was a question, Jackson says. If we start the quiz, we have to finish it, or can we come back to it? You can come back to it. Good question, Jackson, right there, 100 points. Shape, center, spread, says Blake right there. Shape, center, spread, says Meredith right there, 100 points. Shape, center, spread. So the first thing we're going to figure out is the shape. So when you look at a histogram right here, you want to ask yourself, which way does the monster man's tail go? So when we do the monster man's tail, it's right to the high, left to the low, whatever way the tail goes. This is very clearly a what skewed distribution. There's the monster man. There's monster man's tail. We say right to the high, left to the low. So it's very clearly left skew. Now, there is a trick, and I do want to mention this. I'm not trying to trick you here, but here's where people sometimes make mistakes. If we have the following distribution, be very careful. Here's a trick. Is this right or left skew? Is that right or left skew? Now, be careful. This is a common error students make when answering if this is right or left skew. So take a vote right now in the chat. I'm going to give you buttons to click. That distribution I'm showing you on the screen right now, is that right or left skewed? So take a vote and we'll see what people say. And then I'll tell you why it is that. So you might have gotten it right or you might not have, but I'll tell you why is this. This is the mistake. People will see it on this, like, well, obviously it's this. And I go, it's 50-50. So we have to know which way the tail goes, right? Now, I want you to remember you're saying right to the high, left to the low. Right to the high, left to the low. That helps out with this because tell me, is Monster Man's tail going to the high side or the low side? Is Monster Man's tail going to the high side or the low side right there? That'll answer the question. Does the tail go to the high side or the low side? Which way does the tail go right there? These are the common mistakes I see when answering these. Does the tail go to the high numbers or the low numbers? It goes to the high. So the common mistake is oftentimes people take this and just turn it this way right here and say, oh, it's left skew. What do you immediately notice about this right here? Exactly. So this is the mistake right here because now he's reversed imaged because the numbers should not go in this order. The numbers should go. If we change the picture, where's our picture? Swap the picture, rotate. It should go this way, right? Numbers should go from low to high. So the answer is that this is a right skew distribution. So if you got it right, great job. Don't worry if you got it wrong. This is where people sometimes make a mistake. If you stack it, oops, well, I want to go to stack. It'll actually show you, it changed my orientation completely. It'll actually show you it's right skew. It's just the most common mistake right there when looking at a distribution that's vertical sometimes, right? Because numbers, yeah, exactly. Does that make sense? Great job. It's right skew. A lot of times what we show you, though, on tests usually is in this sort of format where we can just easily say that it's left skew because the number line is properly oriented. So this is a left skew distribution because Monster Man's tail down here is on the left side, on the low side. So since this is left skew, then it asks about the modal area. Now, you might argue that this is bimodal, but the second mode wouldn't be around 64 to 66. 64 to 66 is right around here. Technically, it's right there. If there is a modal area, it's inside of here. If it's skewed, you use median, correct. So the proper measure of center would be the median. Great job, Jackson, right there, 100 points. But the modal area is going to be right in here. Is there a second mode? Maybe. I don't know. But it's not down here if there's a second mode. This is a modal area and maybe a smaller mode here. This is mostly unimodal with the mode around the 74 through 76, and that's where the peak is right there. Great job, Leah. Check those answers. Get it right. Get those 100 points. So the next question people were asking about, and keep asking those questions because we do a lot right here. The data in the accompanying table are the numbers of deaths from floods. Did I see that already? So flood deaths. Tell me if I miss it. We're going to do as many of these as we can right now. And show up to any officers and be like, hey, Brian, can we do this question? There's so many. See, a lot of them are very similar, though. Life is swingers. We did something like that. Floods. Watch it be a variant on a question. Some of the questions will change the context for you. So we've added more questions this semester, so I have to know all the variants. You got to know a lot. We found it. We found it. Here we go. Okay, we found the flood question. We're going to mark this in the video. I'm going to disappear. So we're going to mark this so other people can come back to it and also see how to solve this question, understand the theory behind it. So Stat 201, Chapter 2, quiz, floods. Here we go. So with this question, the data on the table are analyzing the number of deaths from floods from 21 randomly selected years from this to this. Write a short report describing the number of the deaths of these years. Oof. Oh, wait. What do you immediately notice right here? That jumps out to me really quickly from the rest of the data points. Also, this down here. What do you immediately notice about this? There's very what values on this? There's an outlier. There's very high values. Now, what you could do. So probably I can tell you this data is going to be right skewed. If you have jump open, you can copy to clipboard, copy the data. So I clicked here, do it slowly. Great job right there, Meredith. Big range, outliers, extreme values. So we're going to copy to clipboard, click copy right here, click done, and then go over to jump. Inside of jump anywhere, on a Mac, it'll be at the top of the screen. Go to File, New, Data Table. File, New, Data Table. File, New Data Table. I'm going to go ahead and full screen this. Don't click inside of it, though. Just full screen it and then go to Edit. And I don't think it had column names. It did not have a column name. That was Edit, Paste. I'll pause with what I did. It's Edit, Paste because it did not have a column name. If it said like flood deaths, that'd be a column name, and you have to paste with column names then. So make sure you don't have a column name at the top of your first observation. That should go as a column name, so you'd paste with column names. It's the flawed one, finding the Q3, Q1, and the IQR. We'll find that here next. Great job, Tara, right there. Let's do that next. So here's this data right here. Let's go to Analyze Distribution. That was Analyze Distribution. I'm going to click wrong buttons. Analyze Distribution. This is 201. Jackson, ask any questions you got, though. Analyze Distribution. We're going to double click the column and click OK. Now, we do run into a bit of a problem right here because the way JUMP calculates some of these numbers are different from my Pearson. But if you calculate these numbers, the meteorologist, you bet, Holly, will do that one here next. If you calculate these numbers and use them and it tells you they're wrong, just message me and I'll fix it. I'm going to show you how to solve them without using JUMP, which it drives me crazy. I think there's an instructor comment that says, like, JUMP doesn't solve these the exact way. It's that there's 9 ways statisticians have come up with to solve the Q1 and Q3 because statisticians don't like to agree on stuff. So this is very, very right-skewed data, has outliers with what we were talking about, and we saw that by looking at the data. And we're going to do the next one right here that has us find the values in a moment. They are very skewed to the right. And they are, is it unimodal, bimodal, or no modes? What do you think? That would have been harder to tell without doing it. Uni, bi, or no modes? No modes means like uniform. Uni, bi, or no modes? Uni, bi, or no modes? Uni, bi, or no modes? Are these secondary modes? Is it like bimodal because of this? We drew a graphic today in class talking about the modality that if we're going to go out and climb mountains, we really want there to be 2 mountain peaks for us to climb up, 2 strong, definitely unimodal. So if you see a little like extra thing down there, this isn't like a modal area. That's not a mountain. You really want 2 mountains to climb up right there. So this is definitely unimodal. Great job following along right there. 100 points. Keep it up. Keep following along. So it has 1 mode, and the most extreme value we see right there is the 445. So that is the most extreme value at the far end right there. So let's check our answer. Great job. Now there's another one apparently. Let's see right here. The floods. Let's find that other one right here. So many questions. Where is it? How does it start out? Oh, it's right here, right? Okay, good. We found it. Okay. So this is the flood question again, and we've got data again right here, and it asks us to find certain values, the mean, the median, the IQ, the Q1, Q3, and the range of the data, and also the IQR. Now, the IQR is going to be easy to find if we find what and what first. We're not going to find the IQR yet. Obviously, it's the last question. But the IQR is going to be found by doing the what and what. Put flood questions right here. So the IQR will be found by doing the what and the what. The IQR stands for the range of the middle 50% of the data. So to know the IQR, we need to find the what and what. The IQR is the range of the middle 50% of the data. Q3 minus Q1, which is the range of the middle 50%. Q3 minus Q1, and it's the interquarters, the range of the interquarters. Great job, Meredith, and also Holly right there, and Tara, great job. So with this, let's take our data right here, and here's the data, very similar to last time with an extreme value. We're simply going to do the same thing we did last time and put it into JUMP. Now, JUMP's going to help us find a few values pretty quickly. Sadly, I think it'll give wrong values for some of the Q1 and Q3. It drives me crazy. I'll show you a separate way to solve this using my preferred program very quickly at the end of this, but we're going to solve this your way first. So stay tuned while we solve this the way you should solve it. Copy to clipboard right here. And so we're going to copy with Control or Command C. Now that we've copied it, we're going to go over to JUMP, anywhere inside of JUMP, and go to File, New, Data Table. File, New, Data Table. Make sure you've copied the data. Click on the little thing, copy to clipboard, Control or Command C, File, New Data Table in JUMP. Inside of the New Data Table, don't click in it. A lot of people click in it. Go to Edit, and we're going to paste normal. We're not going to paste with column names because there was no column name. So let's go ahead and edit, paste. You notice there is no column name, which is good. So the first thing I'm going to do right here is I'm going to right click on this, and I'm going to go to sort and sort in descending order. Now I'm going to sort in ascending. What do you notice I see here immediately? What do I immediately see in the data? I immediately see my what? I immediately see my what? I immediately see my what and what. Right there, just visually speaking. I immediately see my what and what. Since I've sorted it, Jump put them in order for me, which I could have done that. I could have written them in order, but hey, Jump did it quicker. The min and the max. Great job, Meredith, right there. Which are part of the 5-number summary, the min and the max. Now that we've got our min and the max, let's think here. If I have 20 numbers, it's like I have 10 lower numbers, 10 higher numbers, and the median would be the what's number. So think about, just like visualize this right here. There's 10 low numbers, there's 10 high numbers, and the median would be the whatth number. So like there's 10 low numbers, there's 10 high numbers. The median would be the whatth number. If you have 21. With 21 numbers, it's like you have 10 low numbers, 10 high numbers, and the whatth number is the median. Does that make sense? And if you're looking to find the median, you can always do the amount of numbers you have plus 1, and then divide that by 2, and that'll tell you the median position. So you can always take, there's 21 observations, plus 1, divide by 2, and it tells you 11th number is the median. So there's the median right there. It's harder with more numbers, but if you put them in order, great job right there. Awesome idea. Or Didi right there. Sorry. Call you Didi right there. Excellent work. Now I want you to look at this lower data set. The lower data set has in it 10 numbers, right? Now with 10 numbers, is there a middle number? Well, they were so nice to us in this, or maybe they weren't. I gotta see right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks to me, let me look. That's it. Do you notice, what do you notice about me marking these spots right here? We'll never have you find Q3 and Q1 on the test. What do you notice about the distances all these numbers are away? Every one of these numbers is what right here? Every single numbers of these is what? Because if you have 11 plus 1, the median would be 6. And then you're adding 6 more right here. So what do you notice about those distances? They're all 4 apart, right? So it's very symmetric. And that's the point of these spots in the data. Like this is where the 25th percentile is. So you've gone through 0% of your data, 25% of your data, 50% of your data, 75% of your data, and 100% of your data right there. So it's very symmetric in the distances things are apart. So these will be the answers to our questions right here that we're looking for. These are the answers you're looking for. So now we go here with the median. We'll get that median. We wouldn't really equidistance. Love it right there. 100 points to the class right there. Equidistance is correct. They are equidistance. And so 93, because it evenly divides the data. Hopefully we didn't get it wrong. 56. Q3 is going to be 131. The range is the max minus min. What is the range? Somebody find the range of the data for me real quick. Just try and practice in the chat right here. What is the range of this data on the screen? This is something we should be able to find by hand. The range is just the distance these things are away. I'll put a calculator on here so I can show you how to get it too. Great job, Tara. And so it's 555 minus 31. There it is right there. There's the range. And so the IQR is done the same way. The range is just the biggest number minus the smallest number, or small minus big. Just make sure it's positive. So what is the IQR here? The IQR is just the range of the middle 50%. It's just a range again. So what would the IQR of this data be? What would the IQR? That's kind of one of the newer concepts for us. What is the IQR of the data? What would the IQR of the data be? How would we find the range of the middle 50%? Because there's 50% of the data in the middle right here. Is it 75? I think you're right. So 75, great job, Tara, right there. 75 is found by taking 131 minus 56, and it is 75. Excellent work. So the only one we have left to do is the mean. You can find the mean by hand by adding up all the values and dividing by the total, or you can go right here to the Analyze Tabulate. Analyze Tabulate, all we're going to do is drop our data over here and ask for the mean of the data. So that's one way of doing it right there. Analyze Tabulate. So that was under Analyze Tabulate. Drop the data value in there. I'll show it again. Analyze Tabulate. Drop this right here into resulting cells. Change it from sum of observations to the mean of the observations, and it's 127.43. So 127.43. Double check your answer. Cross your fingers to make sure you got it right. And check answer. Woo! 100% right. So there's a small issue with the way these are calculated in Jump. Inside of Jump, it does slightly different calculations than my Pearson because statisticians disagree on stuff. So there's 9 ways. I'm going to do this quick aside. So here we go with data. There's 9 ways to calculate things. It's a quick way of doing it right here. Wait. Oh, is it? Because right there. Ooh, did they change the way this works? I should be able to click here. Why is it not doing it for those? Well, that's not nice. I'll have to look why that's not working like it used to work. Okay, there we go. There we go. There's my data. Worked really well with crazy huge vectors. Oh, is it because the... I don't know. We'll look at it later. So if I go here to the quantiles of this, the quantiles of my data are the following. If you notice, these are they the same numbers? They're not the same numbers because the type, there are literally 9 different ways statisticians have decided to do these maths. And the 9 different ways are listed below down here in the types with 9 different statistician disagreements, which are used by R, used by SPSS, and then SAS is what we use. We use a SAS derivative. So if you see SAS is doing it, I don't think of the data get chopped off at the last digit. Was that it? And what numbers did we find? Because you notice sometimes they'll differ just a little bit. This is not super duper important, but it's just that statisticians disagree on how to find these answers. And thus, I think these were the ones we found, right? Here is our data, 56, 131. Oh, did I take, I think I pasted different data or something. No, 131. Oh, wait, what? Oh, did some of my data get, no, some of my data didn't. I think I copy pasted the wrong one, but so there's different ways to find these. Let's try one more time right here, and then we're gonna switch. What question should we do next? Data, vector, paste. Did I change some of it? Oh, it did. Whoa, Dee Dee, you're right. Oh my gosh. So I think I'm supposed to click here. Whoa, I destroyed my data. Oh my gosh. Whoa. I altered the data. That was exactly it. You were 100% right. That's why our numbers were coming out so different. Thank you right there. That's worth 500 points. Shout outs right there. That's worth some big points. I didn't even realize I annotated my digits. Oh my gosh. A lot of mistakes in statistics are user error. So, yeah, I ruined the data. I destroyed the data right there pretty quickly. Should have noticed that. But you notice now we get similar answers to what we were getting. I should have noticed my answers were very different right there. But the different ways you do this can calculate slightly different responses just because statisticians disagree on how to calculate the quantiles. Excellent answers. What questions do we have next? We're just rocking and rolling through the questions. I think there was a few more. The deaths from floods we did. So what other 201 questions do we have? There's a lot more questions on this quiz. Someone else is probably here right now being like, ooh, I'm stuck on that question. We've only done 3 of these so far. The one about European drug usage. European drug usage. Did we just find it? We found it. Look at that first click. You do a question about meteorologists? You bet. Holly and Meredith, thank you for asking those questions. And Dee Dee, great job right there catching our error. So let's put right here a timestamp for 26:03, Stat 201, Chapter 2 quiz. And you can drop your questions at any time. I'm going to put these both down right here. European drug usage. And then the other one was meteorologists. So I'm taking notes of your questions so that way we have them. Meteorologists. Would you expect distributions of the variable in part A through D to be uniform? So expected shape. Oh, we think we did that one during office hours earlier, but let's do it. Expected shape. Okay, we're going to try to get as many done here as we can. Let me re-timestamp this. Here we go. Okay. In 2015, the Council of European Drug Usage People, the European Schools Survey Project on Alcohol and Other Drugs, ESPAD, among other issues, the survey investigated percentages of 16-year-olds who had used marijuana. The results from 37 European countries are in the accompanying table. Create an appropriate graph of these data and describe the distribution. Okay. So we have data. Okay, so this is a quantitative amount. We need to display it as a what or a what. So what could this data be displayed as? This is quantitative. This is a quantitative answer. The one about author running? Oh, let's do it. So this is quantitative data. What could we display it as? There's hints in the corner. It's quantitative. Histogram, yep, which they're going to show right there. Histogram, box plot, stem and leaf, dot plot. So that immediately eliminates this is a scatter plot. Nope. This isn't horrible. Please tell me they're not going to pick that. Because I would really think we're going histogram. And then do we have a few low values or do we have a few high values is the question. So if there's like 2 values near 40, then that's the answer. And I see 42, 39, and then there should be another one. And 37. It looks to be that one. And then there's a lot more values down here at the lower values, like 5, 5, 7, 4, 4. And this one would be wrong here because there's a lot of observations on the low end, like 4, 4, 5, 8, 7, 2, 5, 7, 7. So we see concentrations of data down here. And so that should be, well, we can't check the answer yet. Which statement below best describes the distribution? Tricky questions. You ready? It's either going to be unimodal or bimodal. I have to disappear because again, it does have slight bimodality to it. There's like a peak right over here around 10 or so maybe. There's a peak around 20. Let's see if any answer conforms to that. Bimodal with a center around 18 with some countries reporting values near 80%. Oh, no. There's no values. There's no reporting. What's this bimodal? Unimodal. Most countries exceed 30% marijuana usage. Oh, that's wrong. Because if you look at this, most countries exceed 30% marijuana usage. No. And also, this gives it away. Since we're talking about unimodal, bimodal, and all this stuff right here, it can't possibly be the pie chart. So that's a giveaway that we're not doing pie charts because the idea of the shape of a distribution is only coherent if we're talking about a histogram. You can see all these graphics right here. Since we're talking about modality, we have to be using a histogram. So that confirms the top answer. Multimodal with 3 distinct peaks and no country exceeding 10%. Well, that's a lie. So eliminate. With most countries exceeding 30, no, very few exceed 30. That's a lie. Bimodal with some countries reporting values near 80%. These are all lies. And then the answer is right here. It has to be that answer. So does that make sense how we eliminated it? I kind of like this question. You know, you can disagree on the wording on it a little bit. Like, is it bimodal? Is it unimodal? But there's giveaways that some of these answers can't be correct because countries reporting near 80% is not true. There's no country near that. Most countries having more than 30%, that's not true. And we knew this by looking at the data. We could have also copied the data into Jump. And let's go over here into Jump right here. Go File, New. This is not required, so I'm doing a little bit quickly because we're going to do another one here in a second. And with copying this data into Jump, we can see the shape of the histogram itself. Edit, and this time I think we do have column names. And let's go here to Analyze Distribution. And we could double check our work, and you can see the shape right there. This is a what skewed distribution. It looks a little left skewed to me. But hopefully this makes sense right here, how we see very few countries have 30 or more. It's a very small amount. Like, that's not where 30 quite is, but there's only those countries right there. Really good question. Like that one a lot. It's a new question this semester. We're doing a lot of the new questions. Let's check out another one right here. The next question on our list is meteorologists. Okay. So how does the meteorologist one start out? Tell me if I see it. A little thinking music right here as we get this going. Meteorologist question. Tell me if I miss it. Like, Brian, it was this. Oh, here it is. We found it. Thinking music over. The meteorologist question time. 3133. And please drop more questions in the chat as we're doing this. If you're watching this in the future, swing by office hours, ask the question you're stuck on. So start early, ask questions. Okay, so we got a meteorologist preparing to talk about global warming. And click on there. Compiled a list of weekly low temperatures he observed at his southern home last year. The coldest temperature was 36 degrees Fahrenheit, but he inadvertently recorded the Celsius value of 2 degrees. Ooh. Assuming that he correctly listed all other temperatures, explain how this error would affect the measures of center, the mean, the median, and the measures of spread, the range and the IQR and the standard deviation. Okay, so let's draw this out. So they have a table of values that they're looking at, and they're looking at the lowest temperatures. And this value down here was improperly coded. So it wasn't recorded as this. It was recorded as this. So he did this improper right here. And so what would this change now? Let's consider the median. The median is the what? The Wayne Gretzky one? Oh, let's put that on our list, the Wayne Gretzky one. So the median is called the what of the data. Like the median is known as the what of the data. The median is known as the what of the data. The median is known as the what of the data. The median is known as the what of the data. The median is known as the what of the data. The middle, the 50th percentile, right? So does the middle, the 50th percentile change, yes or no? So we just take the lowest number and move it down here. Would that move where the middle number is at? So will the median change? The median, does the median change? Like if I have 3 people and one person has 1, another person has 2, another person has 5, the median is 2. But if this person over here now has 50, it's still the median of right here, right? So the median is not affected by skew and outliers. Exactly. Great job right there, Leah. Good notes right there. The median is not affected, and we've basically moved the lowest number. So if we were to change the lowest number and move it down further, it's not going to change where the median is at. But what would it change? It wouldn't change the median. It would definitely decrease the what. What follows the skew? And this is a great note to have right here. What value follows the skew? So median is not impacted by skew. The median is not impacted by the skew. The mean, exactly. The mean follows the skew. So the mean follows the skew. So it's definitely going to change the mean. So I think the first one was asking about that. The mean will be lower because remember, the point got pulled downwards. So the mean's going to follow that. And the median will not be affected. So the median doesn't change because it's just the middle number. The lowest number goes further away. The middle number is just at where it's at. The mean is going to be pulled in that direction. The range, so we took the lowest number and we made it more lower. Now it's most lowest. Most lowerist? I don't know grammar. So what happened to the range of the data here? The range of the data has done what? This is a really good question. Sometimes I don't love questions, but this question is great. The range of the data did what? What happened to the range of the data? The range definitely whatted. The range definitely whatted. So what happened to the range? So the yellow shows the original, and then the green shows the misentry. So since this point has been moved, we'll put a thing over it like it's been misentered. The range has increased. Great job, Didi, right there. The range has increased. 100 points in the chat. The range has increased. So the range is impacted by outliers. So it's going to be a higher range. But let's look at the IQR, which is also a range. And hint, the IQR is paired with the median for this reason. So the IQR right here would look the following way. It'd be the middle 50% of the data. So we can kind of do a before and after. Maybe the middle 50% is in here. And the middle 50%, will it change? Yes or no? With that outlier there, that pull on the data, moving that point further away, will it change where the middle 50% is at? And this is why we use it. If you're like, oh, the middle 50%. No, great job, Ethan, right there. This is a power hour of responses. Keep it up. Dee, Tara, Holly, Ethan, great job. So that's why the median is paired with the IQR and the standard deviation is paired with the mean. So these are paired right here. We use those together when we're talking about data. So the IQR is not going to change. The IQR will not be affected, but the standard deviation are how things deviate from the mean. So things are more deviating from the mean. Think about this. Our values, if you bring this value down here, do values deviate more from the mean? The mean might be somewhere right here. This might be where the mean is at, which is not a good measure of center if we have outliers. But if you move values further away, do they deviate more from the mean? That's what a standard deviation is. It's a standardized deviation from the mean. So if we move a value further away, we would what the standard deviation? If values are moved further away, just like we did examples in class today, if values are moved further away, we would what the standard deviation. So here's two curves with a standard deviation of 5 versus standard deviation of 200. And if values are moved further away, the standard deviation would be what? So since a value has been moved further away, the standard deviation will be higher. I think we've done every one of these right. Woo! Lucky. Okay, what's the next one? It's the expected shape of data. Here we go with expected shape of data. Let me find it first. Thank you so much, everyone, for being here. Expected shape of data. Expected shape. We've gotten through like 5 or 6 questions so far. You're welcome, Leah. Excellent work. I'm on the screen. Get those hundreds. Really good practice right here. Oh, am I gonna find it? Too many questions. Expected shape of data. There's another one like the one we're doing. Wait, where? How's it start? There was one on the homework we did like that. Is it a homework question? We can do the homework question if you want. For the expected shape of data, how does it start? If you saw it in the questions, let me know. Did we see it? I might have to come back to this. I don't see it. There's a homework one we did earlier like it. We could do it again. But we might have to come back to this. Let me know in the chat. There's a homework question like it. We'll have to come back to that one. If it is the question I was talking about, it's in the homework. Oh, yeah, okay, yeah. We can do that one in a second right here. We'll do this last. Would you expect distribution? Yep. Cool. We'll do that here next. Here, we'll finish off this Wayne Gretzky one. You got it, Jackson. Thank you, Jackson. Let's find the Wayne Gretzky one. So that's the last quiz one we have listed. But drop more questions in the chat. Brian's gonna try to wake up right here. Where is the Wayne Gretzky one? Now I gotta find Mr. Wayne Gretzky. Wayne Gretzky. How's the Wayne Gretzky one start? So many questions. Was that Wayne Gretzky? How does the Wayne Gretzky one start? Is Wayne Gretzky on homework too? We added new questions this semester, so Mubot talking away in the chat right there. Is Wayne Gretzky gonna be here? Mr. Wayne Gretzky? During the 20 seasons, cool. Did I see it? Is it in the homework? It's on the quiz? Okay. Second to last question, Leah. Thank you so much. Let's do the Wayne Gretzky one and drop more questions in the chat because we are out of questions right now. Or like we have one more after this, but drop more questions. 41, 23, Wayne Gretzky time. Here we go. During his 20 seasons, oh my gosh, in the NHL, Wayne Gretzky scored 50% more points than anyone who ever played professional hockey. He accompanied this amazing feat playing in 280 fewer games than Gordie Howe, the previous record holder. The number of games Gretzky played during each season is provided with an accompanying stem and leaf plot, so it's quantitative. Complete parts A through C. So let's view right here the stem and leaf plot. Here we go. So this is the number of games they played, Wayne Gretzky. What does the 5 right here represent? This is the number of games they played each season. So what does that 5 represent? I'll zoom in on it. What does this 5 mean? It was a season Wayne Gretzky played. So that 5 means what? What does that 5 mean? 24? Oh, number 4. Yeah, we'll do 24 after this, and then we'll hop over to the quiz. What does that 5 mean? That 5 means what? That 5 means what? There was a season Wayne Gretzky played hockey in which he played what? What does the 5 right there mean? What does that 5 mean? So this is just a number line. This is the lower 40s. That's the upper 40s. 45 games, right? So it's this 45 is being represented down here with this 5. Just like this 0 right here is the 70 right here. The bunch of zeros right here are all the seasons he played 80 games. It looks like maybe these are playoffs or longer seasons or all-star games. I don't know why there's 81 in some seasons. Maybe they just added a game or something. I don't know. Maybe they just do that. Say, hey, play another game of hockey. You say, okay. Would you use the mean or median? This should be a pretty good one right here to test your knowledge. Mean or median? Look at this data and tell me mean or median. Mean or median? Look at this data and tell me mean or median. Mean or median? What are your thoughts on that? Mean or median? Mean or median? Median, great job there, Holly, because it is what skewed. It is what skewed. It is what skewed. Now, be very careful. A lot of people get this one wrong when we ask what way is it skewed. It is what skewed right there. It is the median. This is a common mistake here. It is what skewed. It is what skewed. This data is what skewed. It is left skewed because it's to the low sign. Remember, left to the low, right to the high, right to the high, left to the low, whatever way the Monster Man's tail goes. So that is a left skewed data set because Monster Man's tail is going to the left side. So because of the extreme skew right there, we're going to use the median. So the median should be used to summarize the center because the distribution is skewed to the left. It doesn't say skewed to the left, but I would still know that. Find the median of the data. Oh man, we're going to have some fun right here. So to find the median of the data, we have to put the numbers in order. There are 20 seasons. So the issue with 20 seasons is that there is no middle number. So if you have 20 numbers, between the what and what number is your median. There's no middle number. With 20 numbers, there's no middle number. So between the what and the what number is the median. If there's 20 numbers between the what and the what number is your median. Because there's 10 lower and there's 10 upper. So you would have to say, okay, so you can do your math. You can do your math trick. If you take the number of values there are, plus 1, divide by 2. So the what number would be the median, or between what and what number. If you take how many positions there are, and you add 1, divide by 2, you can find where the position of the middle. Not the value of the middle, but what position it's in. So what number is the median, or between what two numbers is the median? Who knows? So we have 20 numbers. So the median is between these two numbers. You could also say it's this position, but it's a decimal. Oh, well, the median is the middle number, right? So we would have 10 numbers above it and 10 numbers below it. So when it says what is the median, we want the middle number. So you have 20 numbers. So what's the middle number? Closely, it'd actually be the 10.5 between the 10 and 11th number. Because think about this. If we have 20 people in a line, so we go right here to a line of people. Great job, Ethan, right there. And you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 10 people here. And here's 10 people here. There is no middle person. The middle person would be between, which would be the 10.5. Does that make sense right there? So you can add up how many numbers there are. Just say there's 20 numbers. You can add 1 to that. The math to find the middle position is how many numbers do you have plus 1 divided by 2. And that just tells you the 10.5 number is the median. Now to find the median looking at these numbers, we can start by counting on the low side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median would be the average of what two numbers? Tell me, average together these two numbers, which is kind of not a big deal, and I'll repeat it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you didn't see it, this was 10th and 11th in position because I'm counting in order. So I'm counting from the first, the lowest, second, third, fourth, fifth, sixth, seventh, eighth. This is just a number line. 9th, 10th, 11th. This is 10 and 11 right here. So the median is the average of what two numbers right here? This is the really good practice for the test right here. Like, self median like that. The median is the average of, it's 79 because it's 79 plus 79 divided by 2. Does that make sense? So 10th and 11th are 79. If the median had been between these two, it would have been 78.5. But the median is just 79 because it's where the middle of the data is. So the median is 79. And now it wants, without actually finding the mean, would you expect the mean to be higher or lower? So the mean follows this what? Is there time? Yeah, 320 assignment 2. Yeah, let's do that, Abby. Thank you, Abby, for being here. Yeah, we're going to do one more 201, I guess, after this. And then if you don't get your 201 question today, let me know. We're doing more tomorrow. But great question, Abby, right there. There is definitely time. Thank you for being here. So the mean follows the what? The mean follows the what? I think we took a note on this earlier. The mean follows the what? The mean follows the what? The mean follows what? Can you do the one about the study of the body fat? I think we got enough time, Holly. We got like 30 more minutes. The mean follows the what? It follows the skew. So if this is left skewed, the mean will be what to the median? If this is left skewed, the mean will be what to the median? The mean follows the skew. Like if you have the mean and your median, the mean follows the skew. So Jackson, great job right there. The mean will be lower than the median. So the mean will be lower because the distribution is skewed to the left. And that the skew pulls the mean in a direction. I think we have the body fat. And then was there another one? We have body fat. And then we have, oh, no, we have 26 people want to do. Was it 26? Let me put body fat on here. We did one just like this. So we did this one. So this is, I think it's the same. It's just different data. Is it the same? So check out, this is just earlier. We did the flood questions at about 16 minutes in. Check out this one right here. If you're looking for this one right here, we're going to do a different question just because we did this one earlier and we showed how to get this with putting numbers in order. But make sure to check that out. Similar question, just different numbers. I don't think it should be theoretically different anyway, but good questions right there. We're going to do another one right here. The question was, can you do one about body fat? We put the body fat in here, and then we'll do the picking distributions. So expected shape, and then we have body fat. So body fat. Here we go. Where's body fat? Did anyone see the number on it? Points. Which number is body fat? So many questions. Tell me if you see it. Here we go. Body fat question. Let's do this. Okay. I need to put on music on the in-betweens. 49, 53. Body fat question. Okay. So with this question, it said a study of body fat on 250 men measured of collected measurements of 12 body parts as well as the percent of body fat that the men carried. The accompanying displays a dot plot of their bicep circumference in centimeters. Would you report the standard deviation of the IQR? Okay. So before I even look at this, we choose between standard deviation and IQR by looking at the what or the what of the distribution. We choose between the standard deviation and the IQR by looking at the what of the distribution. Standard deviation and IQR are measures of spread. So to decide standard deviation and IQR, I always have to know the what of the distribution. I always have to know the what of the distribution. Well, that's bad. But to decide between standard deviation and IQR, I always have to know the what of the distribution. Yeah, we might have time, Justin. We might have just enough time. Let me mark that here. Let me mark the other one. To decide between standard deviation and IQR, we have to know the what of the distribution. To decide between standard deviation and IQR, we have to know the what. Keynotes you have to have. To know if we use standard deviation or IQR, we have to know the what of the distribution. To know the spread, which will either be standard deviation or IQR, we have to first decide the what of the distribution. So to pick between the two of these, we have to know the shape. Allison, great job right there. We have to know the shape. So if we're going to use standard deviation, it'll be more normal. If we're using IQR, it's more spread out or more skewed, has outliers. And they go hand in hand with picking between mean and median. Median being the skewed one, mean being the one for normal data. So let's look at this. And it is somewhat what? I mean, does this look more normal or more skewed? Does it look more normal or more skewed? What are your thoughts? Does it look more like a normal or does it look more skewed? Does that look mostly normal or skewed? It looks kind of normal. It looks like there's a little weirdness right here, a little weirdness, but mostly normal. Report the what? IQR or standard deviation? I'd say it looks mostly normal. Mostly normal. It's not perfect. Nothing's perfect. It's mostly normal. I'm going to get super mad if they say it's not mostly normal. So I should report the what? It's mostly normal. So these are you probably want to put this on flashcards. Spread for mostly normal data is what? Mostly normal means for the spread report standard deviation. I'd also pair that with the mean. Great job with there, Allison. So we'd say it's mostly symmetric. Uniform, we're talking about is it skewed or symmetric right here. So it's mostly symmetric. Boom, right there. We got it. A little worried on that one, but still it's mostly normal. Nothing's perfect. It's mostly normal. Look for kind of key shapes right here where it's either pretty skewed or mostly normal. And that's how we pick between standard deviation and IQR. And the same is picked between the mean and the median, reviewed in class today. Really good stuff right there. Really good question. I throw you a little bit of weird data right there. I think we have one more right here we're going to do. Let me put on a little chill music. Clicking all the buttons. Clicking all the buttons. Okay, we got another 201 one coming up. We've got which distribution or how would the distribution look on the homework. Keep those questions coming in. We still got 23 minutes, so we got time to do a few more. Oh, yeah. Got up a little bit early today. Oh, man. Weekend's almost here again. Oh, I think I just saw it. No, that's not it. Okay, here we go. This is a tricky one. 24, number 24 was Ethan. You want to check out 24 real quick when we come back to it? All right, so this is the homework. Okay, so we're here at 54:05. Let's check it out. Okay, so here we are with the expected shapes of distributions. So when we talk about speeding tickets, a lot of people would probably have around what are what speeding tickets. Just think about like, these are seniors in college. A lot of people probably have around what are what speeding tickets. I agree mostly with a lot of their observations here on this data. A lot of people probably have around what are what speeding tickets. What do you think? 0 or 1, right? You've probably done the question, right? So 0 or 1, because there's kind of like a lot of people either have like 1 or 0. I mean, if you get like 20 speeding tickets, you're not going to be driving a car anymore. I hope not. So a lot of people have very few speeding tickets. It's probably going to be centered around that, like modal around that. And it's probably going to be, is it going to be symmetric around 0 or 1 or skewed? So if you think about this, could people get like 10 speeding tickets or 15? If people are getting like 10 or 15 speeding tickets, that's going to make a what to the distribution. So if we have a lot of people getting like 0 and 1, and then if we have some people getting 10, that's going to make the distribution very what? Because there might be like a whole lot of people getting like 0 and 1, and then over here you got like a person getting 10. It's going to be very, very skewed. So just theoretically speaking, there's probably like a modal area around 0, 1, and then there's probably people getting like a ridiculous amount of speeding tickets. So it's probably going to be very skewed, and a lot of people are going to get towards the kind of lower end. Some people getting extreme values. So this is players' scores in a U.S. golf tournament. Now, this one was one of the weird ones. My brain's going to have to reboot a little bit on it. I think this gives some hints to it. Many golfers will score above the mean and few will score below the mean. So what we have right here is there's kind of when you go golfing is some people just have a really great game. So this is what it's talking about. I don't know if I agree 100%. I'd love to run the data on this. But why will a lot of golfers score above the mean right here? Just explain to me with this data, which is a better thing to understand from this problem. If the data looks like this, where someone gets a 58, and then the highest people get in professional golfing is like an 80, maybe a 76. I mean, there might be outliers, but 78, I'll go with that. So why would a lot of golfers score above the mean right here? Here's the median. Why would a lot of golfers, if the distribution looks this way, score above the mean? Why would a lot of golfers, you could say because it's this. And here's a hint. Here's 50% of golfers. That's 50% right here. And this is the remaining 50%. So why would a lot of golfers score above the mean? As Jackson, you might be answering it right there. And not just skewed, though. That is correct. It's because the data is what? And this is what it wants you to think the data looks like here. It's because the data is what skewed? The data is what skewed. The data is left skewed. Yep, left to the low. So the mean will be what to the median? This is mean right here. The mean will be what to the median? The mean follows the skew. So the mean is going to be lower than the median. Does that make sense? The mean is going to be lower because the mean follows the skew. So a lot of, have you done the running movies in the quiz? I don't know if we've done it yet, Allison. We might just have enough time. We might. We'll cross our fingers and try to get to it. So a lot of golfers, over 50%, are going to score above the mean. So that's what we have right here. It's going to be unimodal, one modal area of concentration of data, and it's going to be skewed. And that's a tricky one right there. I wouldn't love that as a test question. A lot of these right here. It's good concepts. Weights of female babies born at a particular hospital. So when you think about this, you probably have distribution of weights of babies are going to be more normally distributed. There are, of course, values that are further away, but you're probably going to have a normal distribution right here and probably somewhat symmetric, where your average baby is about 8 pounds, and then you would have some extreme values on either side, maybe a standard deviation of like half a pound or something like that. But that right there would probably be what we expect. So it'd probably be more unimodal and probably somewhat symmetric. Some babies will have an average weight with about the same number of babies lighter than average. And that goes to the idea of symmetric right there. So the idea of symmetry is about the same amount we'll have above the mean, about the same amount we'll have below the mean. So if the mean is right here, about the same amount are below and about the same amount are above, and we have reached the idea of symmetry. The length of hair. So when you think about this, it'd be very weird to have length of hair right here. Now, weird doesn't mean bad. You can grow your hair whatever length you want. But usually people have what or what hair? Usually people have what? How would you describe? Usually someone has this or this hair, which I'm kind of breaking the mold right here by having this. But usually people have what or what hair. So if you were to talk about someone's hair, you'd say usually there's what or what hair, long or short, which kind of points to hair length being somewhat what of a distribution. So if you say usually people have long or short hair, Brian's hair is a little bit weird. Nothing wrong being weird, as we like to say here. I mean, like, being yourself. That's what I mean by that. So hair probably has a what distribution? Bimodality. And I knew they were hinting at this the last time I did it. And they're saying it might be, they're saying it might be skewed. And the reason they're saying this, which I kind of disagree with, is they're saying there is no upper end to hair length. So it's possible to have very long hair, but hair can't be negative. So what they're saying right here with that last comment, which hints at the right answer of skew, is they're saying that if you have a bimodal distribution of hair, like that, there is the possibility for this to skew to the right here. So it could be like that. Because definitely I've seen people with hair, I mean, gosh, I've seen guys and gals and everyone, pals and everyone with hair just like, I'm just like, I've had my hair past my shoulders, and that's a lot to deal with. So shout out to anyone who has hair past their shoulders, because man, once it gets to here, pull up some videos with, wait, watch this. Watch this, you ready? Hey everyone, welcome to Stats to One. How are you doing this morning right here? How's everyone doing? Everyone doing all right? I think I got something in my hair. Just one second, real quick here, everyone. So I used that video when I cut my hair. So I did that video with my hair right there, where I filmed that over the weekend. Then we cut my hair, and then I like raised back up, and I was like, "Oh, it's so much better! I got that out of my hair, woo!" And I like had my hair like this, or my hair was much shorter. It was my fun like haircut moment. So I did that for all my classes, because if you cut your hair, you got to do something crazy, right? So that was like a year ago. Long haired Brian unlocked. Long hair Brian right there. It's twice in my life I've had my hair to my shoulders or a little bit past. But it's a lot to deal with. I mean, it's so much. You just you gotta like shampoo, gotta condition throughout, gotta condition those roots. Oh my gosh, it was too much. I just couldn't take it. I said, it's too much work. I got a job. my second job is taking care of my hair, and I don't have time for a second job. So I quit that second job. What questions do we have right here? We have assignment. I don't know what I say sometimes. We have assignment 320, assignment 2, question 3. Okay. So let's put the notes right here. BAS 320, assignment 2, question 3. Let's take a look at that here in a second. I quit my second job. I got fired from it. The long-haired people came and said, you can't be part of our group anymore. And I said, okay. I said, that's all right. I'll join the short-haired people group. Or the medium-hair length people group. All right, we're opening up the assignment right here. We'll come back and do some more 2-1 here in a moment. 320 starting up here in half a second. We're about to join the medium short-hair people here soon again. 102.58. Let's go check it out. Okay, so I'm going to do similar but different work. If you're checking this out now, I'm going to try not to do your question, but I'm going to try to do something like it. Okay, we got question number 3 right here. The following loop goes through the words Bun, Jackson, Benford. I think we've changed it. Yes, it goes through these words right here. Morty, Jolly, Thump, Magic, Bunny. I need to change those words up there. Jolly. Thump. Magic. Bunny. Change those words up there. Inconsistencies. Sorry about that. We'll fix that up here in a moment. Re-upload this. Probably need to. Let me save this. Re-upload it. Let me save it as update. Let me fix this right here real quick. And make a quick update. Because it was inconsistent. Insert, document, upload, downloads. There we go. That should be good now. And then save. Here we go. Okay, so use the words. Oh, yeah. Well, no, use the words that are in there. Use the words that are in there. So it should have. Does yours have in there currently Morty, Jolly, Thump, Magic Bunny? Morty, Jolly, Thump, Magic Bunny. Does that make sense, Abby, right there? Does it have Morty, Jolly, Thump, Magic Bunny? Some bunny words in there. Could put flop in there and all that good stuff. But should have that right there. You're so confused, Allison. Is this are you in 201 or 320? If you're in 201, no worries. If you're in 320, I'm going to go into great detail. Awesome. So those are the words that should be in there. It just wasn't consistent with this up here, so I changed it. So if you run this right here, let's look at, Sam Jackson says, let's look at line 85. What does line 85 do? Can you explain 85 to anyone in 201 now and say, oh, it's going to do this when I run it? So try right now, explain to anyone in 201 what line 85 does. If your whole grade in the class depended on you explaining to a 201 student what line 85 said, what would you say? How 300 points. What would you say to them? You'd say, oh, that does what right here? What would you say it does? Your whole grade rests on this. Or did you want, it says Q3, but assign a vector to Y. Great job, Abby, right there. That's worth another 100 points. Great job. So it's going to create a blank vector of nothingness into Y. You could do something like assign the value 5 to Y. We're not going to do that, but that just assigns it. C concatenate is a blank vector with nothing in it. So it's just creating this spot for us to put things into. So the first thing we're going to do right here is when we run this, it's going to assign the word Morty to word. Does that make sense? So I'm kind of talking you through what the loop does. It's going to assign Morty to word. This is the answer to this. It's going to assign Morty to word, then run line 87. Then it's going to what? Use the 4-letter word right here for what we're doing. It's going to what back up to the top. After it assigns Morty to word and then runs the skeleton, it's going to what back up to the top. So after it assigns Morty to word, runs the skeleton, it's going to what back up to the top. This is 1B. Might have wanted a different one. It's going to loop back up. Is this the one you wanted, Allison? Because this is 1B, even though it says Q3 right there. And then next, it's going to assign Jolly to word, and then it's going to run this code right here. Then it's going to run thump to word, or assign thump to word. Then it's going to run this code. Then it's going to assign magic to word. Then it's going to run this code. Then it's going to assign bunny to word. And then it's going to run this code. So when you think about it, the loop is going to do all this work for us. And you can see it happening right here. Let's watch this run. And you see the vector y now has those elements stored in it. They're all 5-letter words. If we change this to flop instead of thump, now don't do this, you'll see flop has now been added as a 4-letter word because this assigns the number of characters to word and stores it to that position. So we're saving into position y word, which is position Morty to begin with, because Morty is word the first time. So I'm going to do a very similar type thing here to show you what you need to be doing. Let's say a question asked you, if we had the following. If we said x blank vector right here, this is 320. This is 320. No worries, Jackson. This is 320. 201's like, wait, what's going on? I like it right there, Jackson. And if we had I and vector 1 through 5, x store into I 2 times I, or I times 2. Okay. So let's figure out what this loop is doing right here, Abby. You ready? Do you know what the output of this loop is before I print it to the screen? Can you figure out, don't worry if you can't figure it out, but can you figure out what this loop is going to make for x just with this code I currently have on the screen? I'm going to zoom in so you can see it. With this code currently on the screen, what will this loop create for x? So this loop reads, I will go through the values 1 through 5 as it runs. We're going to assign to the position I the first time it runs, correct. The first time it runs, it's going to do that. But it's going to run 5 times total. It's going to store positions to positions 1 to 5 of I. And so it will make a vector, super impressive right here. The end result of this will be 2, 4, 6, 8, 10 as a vector. Does that make sense? Because the first time it runs, and this is the answer to the question. The first time it runs, this line of code does what right here? Take some guesses, and great work, Abby. You're doing great. The first time that runs, and this is the answer. This is like how to do the answer. The first time it runs, line 92 does what? Like when line 92 runs and initiates, it's going to do what there the first time it runs? What will line 92 do the first time it like initiates? Exactly. Great job right there. And Parker, so good to see you. It's going to go I save into 1. And then line 93 is the what? You know him. You love him. Line 93 is the what? Which never changes. Line 93 is the what? Which never changes. This thing inside of us right here, this thing inside of them there, that skeleton right there, Kyle, so good to see you. It's the skeleton right there. The skeleton never changes. So now we're going to whoop back up to the top. Use those words that we know and love. We're going to whoop back up to the top. I'm going to make this loop shorter so it doesn't go off the screen. We're going to whoop back up to the top. Say that word. We're going to be like, we're going to go this. We're going to go here, then here, and then we're going to whoop back up to the start, like the control panel of it. 4-letter word for what we're doing. We're going to whoop. So we go here, and we go I is 1. Then we run the skeleton, which is just the same code every time, never changes. Then we're going to whoop back up to the start of this, which is what we're doing. We're writing a for this. It's called a for this. Because we're going to go whoop, 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 whoop. Can we do the BS? Yeah, I think we're going to do it. We did one like that earlier, James. We might not have enough time, but we did. I think we did it earlier today, office hours. Check out morning office hours. We might not have enough time. James, great job right there with the loop. So we're going to loop. I think we might have done it during morning office hours. Let me look. Morning office hours. We did it at the start of morning office hours. Check out morning office hours. Start of morning office hours, 3:55 right there. 8C. Check it out. Thank you so much. Question 7. We did that, I think, earlier last week. We might not have enough time, Kyle, because we're getting to the end. Thank you so much, everyone, for being here. I have a meeting and stuff in a little bit, but I don't have to end too soon. Thank you, everyone, for being here. Show up, and we'll do as many as we can. This is what we've done so far today right here. Good job. So that is in there, Kyle. Check it out. Remember, we timestamp every video. If you need me to find it for you, Kyle, I can try to find you where we did question 7 and talk through the theory behind it. I think we have done that one. Or post on the Discord, which during class. You're welcome, James. Thank you so much. So when we loop back up here to the start, What will it do now that it's here at the start? This is the answer to this question. Like, if you know what this is doing, you can solve the other one pretty quickly. So when we loop back up here to the start, what does it do now? What does it do now? So it said I is 1, then it ran this code, then it loops back up, and it now says what? Boom, Abby, right there, you got it. I store into 2, and then it just runs the skeleton. Can you guess what it does when it loops back up here to the start? This is going to assign I into 3. It's going to go right here and say I store into 3, run the skeleton, and then the loop ends because it's gone through the vector of values. I think a really good way, I figured out a pretty decent way to do this. Watch this loop right here, and I'll let you see what's going on. I think people are oftentimes confused because if they see for I in letters, let's go right here to cat letters, and people would say, well, Brian, I is just Z. You see how I is Z right there? Oh, and it counted the letters multiple times, did it? Oh, for I in letters, cat letters. Oh, no, cat letter I. For I in 1 through 26, cat letters I. There we go. So now, well, it's just, people would just say I is 26. You notice that people would be like, Brian's I is 26 right there. Well, watch this. You ready? System sleep. System sleep puts your system to sleep for half a second right here. So if you watch this right here, the loop is running, but it's sleeping a half second between. Does that make sense, Abby? The loop is sleeping a half second between it. I'm going to slow it down a little bit more and give it a second sleep. So the system, like the R, just like shuts down for a second in between each run of this loop. So if I pause it right here, take a look. It's 6 because F is the 6th letter. While the loop is running, you don't get to see this update. It's not going to like show you because for some reason R just doesn't update that. It's kind of a bummer. I wish I could see it. But if I pause it right now, I is the 9th letter of the alphabet. So it currently was running I equal to 9. So inside of R, it had I stored as 9, not that I. But this I here was stored as 9. Like, I'll run it one more time real quick. And if I stop it immediately, it's going to have 2 because 2 is B. So it currently was running I is equal to 2. And then it was catting to the screen 2, and then it fell asleep. So I stopped it before it changed to what I is. Does that make sense, Abby? Maybe seeing this? Like, it's assigning a value of I every time it runs the loop, but I'm putting it to sleep for 1 second so I can stop it. Like right here, it's going to sleep a little bit less. And so if I hit stop right here, all of a sudden now it's like it stopped right there, and I was assigned to 12. So I hope that kind of makes sense of what it's doing. It's constantly updating I right here. How can I see if this works? Swipe season 2. Well, it should. Check this out if the code works. So it's not about the code working, it's about unraveling it. So it's not about your code working, it's about understanding what the code is doing. So you're being graded. So to see what it creates, run the vector Y. I changed mine a little bit right there to flop, but run the vector Y, and it should have created the vector Y right there, which stores the positions, the words, and the number of characters. Does that make sense, Abby? So you should have the vector Y created. Yes. So it doesn't, the for loop, like you don't see it do anything. It's creating and storing into the vector Y. So you can see up there the global environment. Bunny was stored last because that's the last thing it did. Just think about, does it make sense how I'm kind of telling you like what the loop is doing? Like when the loop runs, it assigns to the variable the first element of the vector, then it runs the skeleton. I have Bunny stored. Because watch this. Here, let's do the same thing here. We could go right here and do a system sleep on this, which I wouldn't suggest doing, but I could do system sleep, and I could have it sleep for 1 second, and I could run my for loop and watch as Y. Oh, it doesn't. Here, we gotta stop it. So I stopped it while it was doing magic. Does that make sense? So I stopped it while it had the word stored as magic because I stopped it like 4 seconds in. So if I stop it a little bit quicker right here, well, we just ran Y. Here, we'll stop it. I probably went another 4 seconds. I stopped it on magic again. Here we go. Now I stopped it a bit quicker, and it stopped on Jolly. So I stopped it after a second. So the loop is doing that. I understand the loop, I think. Nice job. Yep. So when you run it, it actually has the last thing stored in because the loop has completed, and the loop will always end with the last element stored. That's why I would be 3 in the global environment at the end. because at the end of the loop, it has the last element stored because it went through all the elements. So if we slow down the loop as we did right here, we can actually see what it's doing. And then we could hit stop technically and be like, okay, M is the 13th letter of the alphabet. So good stuff right there. Understanding the theory is what's important, that it's updating the value of the variable with the elements of the vector as it loops through and keeps doing it. Well, we got one more question on the list for today. We got 474, homework 1B and 1G. 1B, so 474 BS, 474. Let's go to the main screen. Thank you so much, everybody. Amazing office hours. I'm so psyched. Sometimes it starts out slow, but we got that energy. Okay. I've got the questions listed. Thank you so much, everybody. Remember, show up here, ask those questions. And Abby, check it out. We're about to do some 474. So if you're wondering what's coming up, you're about to see more of the advanced work. It's kind of a review of what we've been doing. So check it out if you're interested. Okay. 1B, was it? 1B. It's 474, 1B. Yeah, my screens are oriented. 100 points, everyone, for being here. 1B at 118. 13. 1B. Let's do it. You can actually go through the questions quickly by using the table of contents. So we're down here at 1B. Now with 1B, it wants us to make a sequence of numbers and add them up. So you can actually do a lot of vector mathematics here. Similar but different work. If you make a sequence of numbers, the quickest way to make an integer sequence is to do something like 10:20. That does the numbers 10 to 20. So if I wanted to do something like, and I'd probably put in a parentheses right here. If I wanted to do something like 2 raised to these values, I can find 2 raised to all those values pretty quickly. Where are the questions posted? Which one, Allison? Which class? Questions posted for which thing? 474 will be posted under the assignments under the modules. Let me know if you're looking for something and which thing you're looking for. So if we're trying to make this sequence right here, think about how this looks. This sequence right here, and I don't want to show the answer too much, but it would look like 1, and I think it might make more sense if I do the following. That's 1 right there. So the sequence of numbers looks something like this, and it would keep going. Like you could technically, I should count as right. But if you wanted to do this, look at what's changing and where we could do the vector math. Remember, we can just use a vector of numbers. If we see a vector of numbers right here, that the numbers, can I bold that? I'll start. If we see a vector of numbers, we could turn it into a vector and divide by. Like, like 8 divided by the numbers 10 through 20. That'll do vector math right there. It'll just divide 8 by all those numbers. So we can do something like that. And additionally, you can always take, if you want to view these things as fractions, as long as you have the mass package, you can go library mass and run fractions on it. Whoops, where's my fractions? And that'll tell you the numbers as fractions. Like the last number here is 2/5 right here. So, because it's 8 over 20 divides out to be 2/5. If you want to take the sum of this, you can just do the sum right here and get the sum of it as a ridiculous fraction. So you could report it in fractions, or you could report it as a not a fraction. I might try to do those things right there, like report as a fraction, report as not a fraction. You could say something right here like as a fraction, or you could say something right here as a number. So those are the 2 ways to like kind of report something if we're doing a vector of values and turning it into. Might make sure that this is, I think it's fine, but I like to put things in parentheses. I'm going to have it evaluate. Same answers, right? Same answers. But I'd probably have it evaluate. I hope that helps out with this one right here, seeing the pattern and what we're trying to do and how we could turn things into a sequence and use sequences to do vector mathematics. But pretty good stuff right there. Good questions today. Next one we have right here at the 121.28 mark is 4G, and we're going to use the quick note right here to go down here to 4G. 4G says, we're going to use write a command that prints to the screen the answers to the following questions. 4G says, what fraction of the tomato meter are NA? Calculates by taking the mean of a logical condition. So if we have data that has NAs in it, and once again, we always like to say Brian does similar but different work. If we have data such as like a vector of information, we could make a fake vector here with a bunch of NAs in it. And I want somebody to tell me there are 4 things in this vector. What percent of this vector is NA? So there are 4 things in this vector. What percent of that vector is missing? NA means missingness. It means there's nothing in that spot. So what percent of the vector is missing? There are 4 things in that vector. What percent of that vector is missing? 50%, Justin. 100 points with your great job, Justin. 50%, right? And feel free to ask any questions you have. Great job. So I could do the following. I could ask, is it NA? So the function is NA asks if something is NA. So right here, we see that the first one is NA, missing. The second one is NA, and NA just literally means missing. It's a special character. That's why it's colored differently than typing things like Brian. Brian is an object Brian. Brian doesn't exist. I do, but not in the R world. But capital NA stands for missingness. Don't type lowercase na because that is the character lowercase, or the, not the character, excuse me, that's the object lowercase na. This is the character string, which is words NA. Notice the color changes. That kind of clues you in on between numbers and special characters. The colors are going to really help right there. So we need capital NA, and it has the color change indicating there's nothing there. It's like I asked somebody, how many slices do you want in your pizza? And the first person says, and the second person says, and the third person says 8, and the fourth person says 8. Now there could be a fifth person who says 0, another person who says 2. Like, how many slices of pizza do you want? So we have no information from the first, second person, and we have information from others. If you notice, when we check is NA, it tells us is something NA. So what could we simply do to a logical vector? If we have trues and falses, and we want to find out the percent of trues, we could just take the what of that logical vector. And it's because, if you know the answer, say it. It's because inside of R, trues and falses are seen as 1s and 0s. So what could we do to a logical vector to just find out the percent of trues? Very quickly, which there's 33% missing right here, because there's 2 out of 6 missing. So what could we do? You say, well, I don't need code. I'll just look at it. You just look at it? What if you got a vector like this? Oh my gosh. You got a vector like this. What percent of that data is missing? We'll just store it as X for the moment. And then we'll go, so how would we, if we have a logical vector, we can find out the percent of trues by just finding the what of it. Very important thing. So you have a logical vector. Logical vectors are just 1s and 0s inside of R, like as R sees it. So you could just take the what of that vector. You could just take the what, because it's just 1s and 0s. Just take the what of it to find out the percent of trues. So wherever you, sum, that'll tell us, good answer, Morgan, right there. That's going to tell us how many trues there are. So this will answer 2 trues. You could do that and then divide by the length, or we could just go right here and type mean, and that'll tell us the average amount like of trues. Does that make sense? Great job, Morgan, right there. We can take the mean. Great job, Justin. So notice how I stored this as X. So I'm going to go mean is NA of X, and there's 12% missing in my data. So rather than somebody going in and looking at this right here and trying to figure out what percent are missing, I can figure out what percent are missing by doing mean. And then I can go sum and tell you how many. There's 70 missing values in that data set. Does that make sense? Like looking at that vector, which is the number of drinks vector, it is, what is the number of vector? 19. So right here, you can see that there is missingness in this data. What's really cool is you can actually look at a full data frame and go is.na of survey data. And that's doing it for everything. So we could do the sum. And in the full data frame, there's 221 missing values. So you can find out how many missing values there are in a data frame. But with 579 observations, 47 variables, we have 221 observations missing. I think it'll work fine if we do mean too. So less than 1% of the data is missing. Still something. You could actually find out complete cases. So complete cases means that the row has all the information. Then we could find out the percent of rows with all the information. we could find out the percent of rows with missing information like that. So 18% of our rows have one or more missing values. So we could actually eliminate and go to no missing data pretty quickly. This is just an appending. So let's call this X, or let's call this complete, and store the complete cases into here, and go to survey 09 and take the complete rows. And now we have the complete data, and let's say a complete survey. And there we go. And we can even check to make sure it doesn't have missingness by going here to is.na of it and take the sum of it to see if there's no missing data. Do we want to replace our missingness, not use missing data, all those things, but complete cases tells you if a row is complete. And so there's lots of cool things we can do here pretty quickly with code, like taking just complete cases, which just complete cases tells you, does a row have all the information? So if you see a true, it means that row does have all of its information. So this is a row complete case, and I asked, is it not complete by doing the not? But a true right here means the last row of the data contains all the information. Like we asked 47 questions, and so all the questions have answers. So a lot of great stuff right here. Really great review. Any last comments or questions? Woo! 474, 320, 201. Great job today. Lots of questions. I see I got a full Discord. Full Discord. 201 is super excited. Oh man, business analytics side tonight. Well, with that, we're gonna head out right here. Great job, everyone. Great job, Justin. Great job, Morgan. You got this. Keep asking those questions. I'll be answering more Discord a little bit later. Until then, bye for now, everyone. You're welcome, Jackson. Great work. Bye, everybody. Keep it up, Morgan, Jackson, and Justin, and everybody, and Allison.